All right, everybody. Welcome back to the Digital Cash Evolution. Go ahead and give us a call if you're wanting to get some free coins. You set up your wallet with the Edge wallet. Go on to the Play Store or whatever, iTunes, wherever, whatever kind of phone you got, and check out Edge Wallet. Download that. Give us a call here at the station at 602-277-KFNX, and the producer will take your number and we'll give you a call back and set you up with some coins. And let's get back into it. We're talking with Colin Cantrell, who is the creator of Nexus. And I asked you a question actually earlier, and I wanted to get back into that. So Microsoft took over GitHub. What does that mean for cryptocurrencies?
I think any statement on that right now would be an assumption. We don't know yet. Maybe they might start censoring. Maybe they just want to get on it. I think a lot of people are going to probably move away from that. But I mean, I think the biggest thing, at least what it means to me, is that I think it outlines the need to have a little bit better of a code maintenance system. Most people think Bitcoin is Bitcoin Core, which is just a GitHub repository and an organization there, and that's where everybody references for code. So repositories like GitHub, they were originally just to streamline developers, but I think we're going to see more and more potential issues coming with this. And the Microsoft thing, I think, is possibly something for people to start thinking about and saying, well, do we really want to have this code here? And then how do we decentralize or distribute the code repository?
I mean, exactly. We're talking about decentralization. You're talking about putting up CubeSats, and here's Microsoft trying to take over, GitHub.
Yep.
So obviously the powers that be are trying to stop decentralization, and here we are out here trying to, make it expand. Go ahead.
Well, so, I mean, on the comment on that, I would say, yeah, there's certain aspects of course, they're going to try to take it over because it threatens our system. I mean, if we've seen certain things with the United States, that kind of happened with the federal government, or good things, they always, like as Ernie says, if they can, they will. So,
right,
I mean,
right.
What are the weak points? What are the fail points? What are the central points? And the code repository in development is a central point that can be co-opted. And, seeing Microsoft taking this over, I think it's going to make people start thinking about it and saying, well, what do we do about this? Do we move to GitLab, or do we try Bitbucket, or do we try our own hosted Git? But then again, that's still centralized if the development team is the one that controls it. How do you make it so anybody can collaborate, but you still maintain the quality of the code through pull requests? Because you don't want anybody to just type hello world into the code. You'd want to make sure it's good code, but then how do you make sure that doesn't just get concentrated into a few hands?
Would Nexus, with their new technology, have a solution for this?
I mean, I have some ideas, yeah. I mean, I've thought of, there's a couple different ideas. One of them, which main consensus rules, let's say block size. What if that was a transaction that was read, like a UTXO set, and a consent was signed off on developers that were, let's say, ratified by the network, and you have a better voting system? Or what if we utilize the blockchain as a form of storage mechanism, and every commit is a transaction that contains the data of the code changes? And so when you do a git pull, you're actually pulling from all of the indexes that have all of that code based on the commit history. There might be some options with that. I mean, we're not looking at building use cases like that just yet, because the ledger itself needs to be capable of scaling that. It's like building something, an upside down pyramid. If you have a small foundation, it's not going to hold the weight of everything else. So that's something we're going to explore in the future, definitely, and possibly explore GitLab or self-hosted Git. But I think the future is very possible, and I think some sort of automated development on-chain could be a possible solution.
I know. It's like the more they push back, the more, these cypherpunks just come up with 100 different solutions. So I think, they're trying to fill
things.
Yeah, they're trying to fill a bucket full of water that has a pretty big hole in the bottom. So it's not really going to work. We were talking about blockchains earlier, and the blockchain, the Bitcoin blockchain, is a 3D blockchain. I'm completely lost on this. What you told me earlier was the best, description that I've heard of it yet. Can you dumb it down a little bit so we can understand what a 3D blockchain is, and how is that really more secure than just a traditional blockchain?
So it gains its level of security by having checking and balancing. So just like the United States government was designed to have checks and balances of power,
it's designed to, but
it's we've seen the folly in many of those things. But the merit of the design is still the merit of the design. Maybe the implementation was just incorrect. So it has 3 levels of locking: level 1 and level 2 and level 3. Now you have a weight and a trust associated with you as a cryptographic identity. So if I am somebody that's constantly doing validating on the L1, I'm going to build up time, and that's going to basically increase my reputation. And increasing that puts the attack vector in time. So if somebody wanted to try to attack the network, they'd have to spend years trying to build up their trust enough to be able to manipulate the consensus. So the L1s, think of those as kind of parallel canals. A blockchain is kind of like a river, and it only has so much capacity. And as soon as there's too many transactions, you get backlog or backflow, and it dams up and it overflows. So what we're doing is, as the node counts increase, you'll be able to have parallel canals, right? So that transactions can be assigned to each canal, and then they can be processed in parallel. But the problem with that comes is if one channel, let's say, conflicts with another channel, and you don't have some sort of consensus mechanism in order to deal with those lock conflicts, then you degrade into kind of an easy to manipulate system. So that's where the L2 locks come in. So those are going to actually be checking every one of the canals and making sure that they don't have any conflicts with one another, and they're waiting with stake. And then obviously they have trust associated with that, which continues to build it. And then the final one is the miners, and then they check the L2s and then make sure that the L2s validated everything properly. And if somebody, let's say, tries to manipulate the consensus or go and create a false chain, it'll be easily detectable because you can see the main level of trust versus somebody else's lesser trust. And so you can create kind of a cost associated with that. You're not going to get that time if you're not with the consensus. So you solve the nothing state problem, or presumably solve it with the L2s. And then as the miners, being the L3s, checking the L2s, what they do is they weight the data further, but you still allow the benefits of proof of work without relying on the proof of work and without the miner being the complete dictator of the transaction. So think of it as just series of handoff, kind of like how the internet works, where when you make a connection, you go to the DNS service, which then resolves you an IP address, and then that goes to the local ISP's network, hops between main ISP routes, and then goes internally, and then it hits the router, and then it goes to your own internal network. And so the tiered scaling is how the internet has been designed to scale. So it's a similar type of concept, because without parallel processing, things just simply won't scale. And if you try to do parallel processing with only one consensus method, like side chains, what's going to happen is the security is going to degrade every single chain you create off on the side because there's less validators. And the security of a blockchain comes from the total number of validators or the total amount of computing power of the validators.
And then what about the transaction time? Say, like with Bitcoin, it's what, 7 per second, or has that increased with SegWit? And what is the transaction time for Nexus?
Nexus can do 60 to 70 transactions per second as it stands right now. But theoretically, as we get the 3DC built, it's going to scale with the node count. So instead of having a software bottleneck like we have, where you have a limited block size, even if you have the node capacity, it's going to scale with the total number of nodes that are capable of processing for it. So I don't want to make any claims on any numbers on what it should be, because it's still being engineered, but the architecture is being designed to be able to expand as it's needed.
So right now, Bitcoin and many of the Dash and the others are the main use case is currency, and that's they're looking obviously for many other use cases in the future. But
It's
for Nexus,
digital
are you envisioning use cases similar to some of the other digital currencies, just doing it better, or are you looking at new use cases, entirely new use cases, consumer application or commercial applications?
Yeah, a lot of that's outlined in the Tritium white paper, if you guys want to take a read, but that kind of goes into our software stack. So you have the first level, which is your network level, and then the second level, which is your ledger level, the third level, which is the register level, fourth level is the operation level, fifth level is the actual API level, sixth layer is the logical, and then the seventh layer is the interface. So most consumer applications will be running on layer 6 and layer 7, and then they can interact through an API to make it easy to use. Now, we don't know every single use case, just like internet engineers didn't know everything that the internet would become. So what we're working with the stack is on the operations side and the API side, businesses to be able to come together in working groups and standardize and say, well, we want our supply chains to function this way, and we want private medical records this way, and we want to define this metadata for copyright formats this way, and so on and so forth. The sky's the limit. So we're kind of integrating a little bit of social technology in with the actual blockchain technology to kind of make that easier for consumers to adopt, and also to let us know the specs that we need to make it so that you don't design something to be overcomplicated and too generic. You make it more specific processing, so each API functions for each specific industry and how they need, and creating a more collaborative spirit rather than a competitive one like we experience generally today.
So you're building a protocol and a platform and allowing other people to come in and whatever their creative minds can think of to build on top of.
Yeah, and to help standardize how it functions and what it does to make sure that what they want to build on top of it is scalable and usable.
Awesome. And so we're coming to break, and don't forget to come out tonight at the Monastery Bar and Grill. And what was that address again, Doug?
4810 East McKellips Road in Mesa.